Okay, so let's see here. Let's look at the first page of section 12.1. Okay, so we want to be able to understand the relationship between rational exponents and radicals and roots. Okay, so a radical is just, the square root sign's a type of radical. Um, in a square root, it is understood that we are talking about the second root. So there's a 2 here outside the radical that we don't write when we're talking about square root. Okay. So, um, just make sure the square root means it's the second root of the number. Also, when we find a square root or any other number root, we want to find the number that would multiply by itself that many times to equal that number that we're trying to find the root of. Okay. Anyway, so the first part here is just to understand how can we write a square root as an exponent? How can we express a square root using an exponent? Okay, so if we start out with the statement, the square root of a is equal to a to the m, what is m? All right, and these steps would show us what that is. Okay. So first thing we want to do is square both sides. All right. Well, if we square both sides, what is the square root of a squared? What is the square root of something that's being squared? Well, the square root of a squared is just a. Okay. So the square root of a squared, square root, say if it was a 4, if we did the square root of 4 squared, that's just equal to 4. Okay. So anytime you're taking the square root of the same number you're squaring, you're just going to get the number underneath the square root. Okay. So next step, that's a. So you get a equals a to the, well, how can we simplify here? A to the m to the 2. We can write that as just a to the 2m. Okay. So you make sure you fill out your paper there. All right. This one says that we're going to use the definition of the first power. What it's saying there is if we have a term or a number that it doesn't have an exponent there, that does mean that that exponent is to the first power. Okay, so that would be a to the first power. All right. Next step, it says if the bases are the same, we can equate the exponents. So since both of these are base a's, then we can actually go ahead and just set the exponents equal to each other. Equate the exponents is what they call it here. In other words, we can say that this is 1 equals 2m. Okay, well, what do we need to do to solve for m there? Well, we need to divide both sides by 2, and then m would equal a 1/2. So the square root of a is equal to a to the 1/2 power. In other words, if we have something that's a square root, then that's the same as having it written as an exponent of 1/2. The square root of a is equal to a to the 1/2 power. Okay? All right. So what I'd like you guys to do, I'd like you to do at this point is do the second part. Basically, you're going to use the same thinking, the same understanding. You're just going to do it with the cube root rather than the square root at this point. Okay, so let's go ahead and pause the video while you complete that next part on your. Okay, so after completing that next part, we can see that having the cube root of a number is equivalent to raising that number to the 1/3 power. And those things are equivalent. That means they're the same. The cube root and an exponent of 1/3 are the same. So if you were in your calculator to type in, say, the cube root of 27, you would get the same answer as if you did 27 to the 1/3 power. Both those answers would be 3, because 3 times 3 times 3 is 27. So the cube root of 27 is 3. 27 to the 1/3 power also would give you the same answer of 3. Okay? Let's go ahead and look at the next part. Okay? Where we want to be able to translate between radical expressions and rational exponents. So I'm going to give you a few moments here. I'd like you to take a few moments to go ahead and read this first part. Read the part here in the middle there. Go ahead and then let's pause so you can read that part, and then we'll look here where we actually got to fill in some information on part B of the next part. Okay? All right. On A, we want to simplify 81 over 16 to the 3/4. Okay, so make sure you fill this out on your paper, please, as we go through it. All right, so the denominator, that's going to be our root number. So that'll be a 4 there. Then the numerator of that fraction, the 3, the top of that fraction, that's going to be the exponent that goes on the outside. Okay. So now then we need to do, in order to simplify the next step, we want to do really just the part that's inside of the parentheses there. Okay, the 4th root of 81 to the of 81 over 16, the 4th root of 81 over 16. The 4th root doesn't have really a special name like square root or cube root. At that point, you just say the 4th root, or the next one would be the 5th root. Okay, but what we would need in order to simplify this is a number that would multiply by itself 4 times that equals 81, and a number that multiplies 4 times by itself that equals 16. Okay, so what times what times what times what is equal to 81? The answer to that question is 3. Now that's something certainly you could just type right into a calculator, and it would tell you as well. Teachers, this is to let you know the bells are back on. Please do not release any students until the bell rings. Thank you. Okay, the number that multiplies by itself that equals 4 times that equals 16. That number is a 2. 2 times 2 times 2 times 2 is 16. Okay, so the 4th root of 81 over 16 is 3/2. In other words, if you multiply 3/2 by itself 4 times, you get 81 over 16. Okay, now then I need to do 3/2 to the 3rd power. To do that, I would do both 3 to the 3rd power and 2 to the 3rd power. 3 to the 3rd power, that's 3 times 3 times 3, which is 27. 2 to the 3rd power is 2 times 2 times 2, which is 8. Okay, so these rules that we're kind of using to do this simplifying, you can get them by looking at this rules of exponents document that we should have. Okay, so if you look at that document here, okay, that here's the one that says if you got an exponent there on the outside of a parentheses and a fraction on the inside, then that exponent needs to be applied to both the numerator and the denominator of that fraction. Okay, which is basically what we did, because we had on that last problem, the last step, we had, what was it, 3 over 2 to the 3rd power, right? Okay, well, that meant we needed to do 3 to the 3rd power over 2 to the 3rd power, and that gave us the 27 over 8 when we took both those to the 3rd power. All right, next one. XY to the 5/3. Okay, so we put the 3 out here, so it's the cube root. The denominator goes on the outside of the cube of the radicand, and this would be to the 5th power. Okay. Let's see, what's the or here? We could, yes, okay, I see. We could write the 5. The 5 can either go inside the radical or outside the radical. Notice it does not matter whether we put the 5 inside the radical sign or outside the radical sign. These two are the same. Okay, that's all we need to do there. Okay, the 3rd root of 11 to the 6th power. Well, here we're going to go and write this as a radical. So the denominator of the fraction is going to be our root number here. That's the 3rd root. So we'll be dividing by 3. The numerator is the exponent inside of the radical. That's the 6. You can actually reduce 6 over 3 to a 2. 6 divided by 3 is 2. And 11 squared is 121. Okay, again, some of this can be done with the calculator. All right, so here we got a root number of 3, a cube root again, a 5th power exponent on the inside. So that will be converted to a 5 over 3. Okay? And so that is how you would be able to convert from radicals to exponents and vice versa, going from a rational exponent to a radical statement.